Welcome to VW 7.8. Today we're going to finish up graphing and talk about how to shift the graph left and right. So first, take a minute and just write down, I call this standard form. Notice how it's A sine B quantity x minus c plus k. You always want to be in this standard form when you're graphing. So let's quickly recap what we've learned. The absolute value of that A, that is your amplitude. The absolute value of 2 pi over b becomes your period. K is our midline, or some people say a vertical shift. And the new part today is this, the C right there. So in algebra, you guys called it like horizontal shift. In trig, we call it phase shift, but essentially it's the same thing. You're just moving left to right. So for our first example, the first question you always want to ask yourself is that standard form? You always want to figure that out. And for most of these questions, the answer to that question will be no. You need to put it in standard form. So let's start there. Y equals 3 sine, factor the 2 out, x minus pi over 2. Now we have it in standard form. Now we can get to work. The amplitude is 3. The period is 2 pi over 2, so that would be pi. We have a midline of 2, and our phase shift is pi over 2 to the right. And I use arrows. The book might say like positive pi over 2 means right, negative pi over 2 means left. I just like using arrows. I think it's more clear. So let's start. I'm going to show you the method that I like doing. So let's start by just doing the midline method. So here's our middle. We have 2 right there. We're going to go up 3, so that's 5. Down 3 is negative 1, which makes our 0 line right there. And again, whenever you do the midline method, make sure you always have the x and y axis as solid lines. Your middle is always your dotted line. Now let's scale it. 1, 2, 3, 4. And let's label. So we know this is pi, pi over 2, pi over 4, and 3 pi over 4. As with any graph, let's not worry about the phase shift right now. Let's just say there were no phase shift. The graph would look something like this. That here in the middle, it's positive sign, so it should look something like this. Here to there to there. Okay, now we understand that that is not the actual graph. That is just the graph that has not been shifted. So there are two ways to do this. You guys could grab this thing and just move it over 2 tick marks and basically graph it that way, right? We can just see that if we just move this thing 2 tick marks, that would be a way to do it. That's the traditional way. I'm going to show you a way that's new, because all of you guys could do that. And of course, under my pi over 2, I'm going to write 2 ticks just for reference. I'm going to erase the graph right here for us. I'm going to show you a method called reconstruction. And it's an alternative to the traditional way. You don't have to do this. So reconstruction is when we're going to take one point. So in this case, I'm going to grab this point right here. And notice how it's 2 tick marks to the right. So I'm going to shift it 2 tick marks to the right. That's going to be right here. And what I'm going to do is I'm going to reconstruct the graph around that point. Which means if I'm up here, the next point should be in the middle. If I go back, it should be in the middle. The next point will be at the bottom. And the next point is back at the middle. And I'm going to graph that. So notice how this method is pretty cool because it doesn't require you extending the graph at all. And now we have a nice sine wave right there. You might be thinking, but that's wrong because that's a negative sine wave. Well, not really, because if I were to draw on the old one looked like this, right there. Notice how if I grab this one and I move it, it'll line up perfectly with the one we just drew. So really, it's just another way of thinking about the graph. So again, notice how if you shift it, it starts lining up with the graph we actually wanted. Now again, you don't have to do that, but it's just another way to do it. To save time, I'm going to skip labeling points. You should label it in your answers, however. I'm just saving time for the video. Let's do domain and range. Your domain is going to be all real numbers, and your range is going to be -1 to 5. And there we go. There's our graph. We shifted it, no problem. Okay, here's our next one. It's a secant graph, and again, you're going to apply the same concept. Are we in standard form? No. We have to factor out that 3. So I'm going to factor the 3 out. Let's answer our typical questions. Our amplitude is going to be half. Our period is 2 pi over 3. We have a midline of -2 and a phase shift of pi over 3 to the right. So we have a lot of things going on here. So let's start by drawing our t. The midline is -2. It's up a half, down a half, so that should be -1.5 or 3 over 2, -5 over 2 or 2.5, and then we'll squiggle for approximate our 0 somewhere up here. Let's label the midline. 1, 2, 3, 4. The fourth tick mark is 2 pi over 3, which makes this pi over 3, pi over 6, and finally pi over 2. So there's our labeling. And again, to graph these, just imagine there were no phase shift. So my blue is going to be the original with no phase shift. A secant graph would normally start at the max, so that's right here. Then go to the middle, bottom, middle, top. So there's the 5 points we need for our secant graph. And I'll use reconstruction because, again, I think it's a little bit easier. So I'm going to grab this point. Pi over 3 is 2 ticks. Let's move it over 2 tick marks. That'll be right here. And reconstruct around it. So here's our new points. And again, we're just following the trig patterns here. And let's draw our secant graph. Wherever hits the middle, those are the asymptotes. And let's draw the parabolas in. Just to be clear, I'll make this 2 pi over 3, -5 over 2, 0, -5 over 2, and pi over 3, -3 over 2. And there's our graph. Let's quickly do domain and range. The domain is x such that x cannot be pi over 6 plus pi over 3k, since pi over 3 is half the period. And the range is going to be -infinity to -5 over 2 inclusive, union 5 over 2 to infinity. And there's our graph. Now here's the last one. This one's going to be a little tricky. For tan and cotan, you still want to put it in standard form. I do think that's going to be easiest. So let's start there. 1/2 cotan. Let's factor out the 2. And from here, if you recall tan and cotan, the first step we always did was find the asymptotes. And I still think you should do that. It will be easier. In this situation, you're going to grab this whole thing. Okay, so grab that whole thing right here. 2x minus pi over 2 is between the regular asymptotes of cotan. So in this case, it'll be 0 and pi. And let's solve for x. So divide the 2 out. So 0 is less than x minus pi over 2, less than pi over 2. And let's add pi over 2. So we're between pi and pi over 2. So here are the new asymptotes. And if you forgot that, you should rewatch the video on graphing cotan and tan. And then we can write down some information here, because once you start graphing, we do need a couple facts. We can see a is a half, the period is pi over 2, the midline is 1, and there is a phase shift of pi over 2 to the right. However, this part we're going to ignore because we already covered the phase shift right here. The beauty of this technique is we actually already shifted it, so this actually covers the shift. That's really nice about the technique. Meaning, when I draw in my asymptotes right now, I'll draw that in for you. By making this pi over 2 and pi, I'm effectively shifting the graph right now, so we're just saving ourselves some time. Now the tricky thing about this is there is a midline, so there's going to be dotted lines pretty much everywhere, so it will be important that we keep all our numbers straight. So I'll use multiple colors to try to keep it clear. So there's pi over 2, there's pi, and the middle number we have is 1, so we know that this is a 1. So if I just skip to our y-axis is somewhere over here, somewhere on the left. We'll just approximate right about there. And our a value is half. So if I go up a half, this should be 3 over 2. If I go down a half, this should be 1/2, which means we can put 0 right over here. And now look at that, our graph is starting to come together. Sorry, I gotta move this over a little bit. Okay, that's better. Our graph is coming together now. Let's label the midline. So you do gotta be pretty good at fractions. If you think about the middle of pi over 2 and pi, that should be 3 pi over 4. If you're wondering how I did that, all I did was I added pi over 2 and pi, and I divided it by 2. So I'm basically finding the average. So if you simplify this, that would be 3 pi over 2 over 2, which is 3 pi over 4. So let's do that 2 more times to get the middle of the next one. So this is 7 pi over 8, and this one is 5 pi over 8. And now look at that, we have everything scaled. So let's put our points down. This is a cotan graph, and it's positive, which means it should just decrease. So let's put a point in the middle, and we'll make this graph decrease like that. Let's draw in the cubic curve, and we'll label it to make it clear. And there it is. There's our graph. Now let's quickly do domain and range. I'll move this on the side. The range is the easy part. That's just all real numbers. That's everything. And the domain, that's going to be x cannot be. Let's look at the asymptote. I'll use pi over 2. And then let's look at this distance. That's the period, or the distance to the next asymptote. And the period in this case is pi over 2. Let's drop your k, and there you have it.